All right. Hello, Andre. This is Brian Raya with the final project, I guess. Uh, so I think I'll start off this entire thing with a short demo of the finished product, so to speak. Go on to talk about the code and the strategy patterns I used or sorry, the design patterns I used. And the final thing is me talking about why I made these specific choices and what I believe I could have improved upon or what I believe should have been done differently. So I'll start off by just starting up the game. So right here is the attractor mode. I'm currently not doing anything. The blaster just chose to sit there and shoot straight forward. Um, uh, the centipede is going on its merry way. The thing that I did not implement on the attractor mode was basically all the collisional systems, the player death, so to speak, and the high score system in the center of the screen. The reason for this being that I've had a lot of issues trying to put that high score system in the center of the screen, and decided it was just better to leave this as a visually appealing thing for the player. So I'll press any key right now and I'll enter the actual game. Centipede enters from the top screen as normal, and I'll just casually go along shooting at it. So here I am getting blocked by mushrooms as usual, trying to destroy this centipede if I actually were any good. So there's the last centipede. I'll try and destroy it if I can. And the centipede gets recreated all the way back at the top of the screen. Here's a flea. So I'll destroy this and the spider, of course. In the top left-hand side of the screen, you can also see the score manager, and you can also see the, God forbid, scorpion. But in general, this is typical gameplay. The current things that are left out of the system and the current bugs. Right there you can see the centipede after hitting a poisonous mushroom drops to the bottom of the screen. So the current issues with the system, number one, is when the centipede gets recreated at the top of the screen. There is a brief second where all the body segments seem to reappear on the screen while it's being basically put back together again. The second issue is basically the regeneration of the field. I ran into a couple issues with that. So rather, when the player gets killed, a brand new game field is generated, a brand new start, so to speak. I thought not having a change in the scenery was a bit of a mistake if I didn't put anything. So rather than keep the same field over and over until basically the end of the game, the game field changes every time the player dies. So there we go again. The next issue that has kind of been a problem is on rare occurrences, the scorpion will get destroyed, and when it gets destroyed, some of the body parts are off alignment, but they still continue their path and still get fed their movement arrays like normal, and they seem to just follow the right path once they're back to being single heads. So also at the top of in the center of the screen, you can also see the current high score. I'm also on my last life. But you can see the current high score and my lives all dropped to 0. this is basically the game. I'll exit out of it now. There's not much after just being dead. So I guess right now I'll just go through all my code, starting off with the blaster, moving on to the critters, and moving on to the design patterns I chose to do. So blaster, as you saw, was here. There are currently two different blasters. There's the attractor blaster, which uses the finite state machine to that uses the finite state machine to plot its course, while the actual blaster takes key inputs when a key is pressed to physically move. So one thing that was asked that we talk about was the choice that we made for the player and its update. So this update I mainly drew from the teal demo, the very first one with the asteroids. I liked the idea of this system because it allowed the ability to implement sort of a gliding system. For Centipede, it doesn't necessarily work out, but I left much of the backbone of that system just in case a designer were to one day change his or her mind about how the ship moves, so to speak. Maybe they wanted to move sluggishly from left to right and faster from up and down. Whatever the case may be, the system that was in place for that copy, I believed, was the best. So apart from that, I guess I can talk about the bullet. So the bullet doesn't hold any information about whether it's alive or dead. It generally does not care. It's just created from where the blaster currently is and just shot straight up. But what does maintain that knowledge is the bullet factory. So currently the bullet factory uses this limiter. And what the limiter does is just ask if there is a bullet that can be created or not. I used a Boolean because it's the easiest way of representing 0 and 1. But if hypothetically a game designer were to say, oh, we want 3 bullets on the screen or 5 bullets on the screen, that could just be easily substituted with any given integer or so on. So the factory is a proper singleton that was shown in class. And what it does is it checks if there is a free instance in the stack, and if there isn't, it creates a new one. Once the bullet is recycled, then the limiter is triggered back to true so that a new bullet can be shot on screen. This ensures that there's always one bullet on the screen, but as I mentioned before, it can be changed depending on what a designer chooses. The terminate function ensures that the instance is reinitialized back into a null pointer to ensure everything's fine and dandy. And the destructor ensures that each individual element within the stack gets deleted, releasing all those news by calling the delete. So finite state machine, this again was mentioned in class. It wasn't one of the things that was basically required, but after it was shown to us, I basically used it for the attractor blaster. I used it for the centipede, and I also used it for the spider. It was extremely helpful in basically having all these switch conditions without having a giant single basically if-else case. It basically saved a lot of time on a centipede that at one point did not work. Moving on to that, I should also mention that never mind, I'll continue on. So right now I'll mention the centipede. There are currently two different sections. There is the centipede head and the centipede body. The big difference between the two is that only the head is able to receive a new set of arrays or offset arrays to continue on its movement, while the centipede bodies basically form a linked list to ensure that they are all connected to one another. So information is taken from the front, and when the front decides that he is done with his information array, it will pass it back on to the second, and then the second, if it had one, would pass it on to the third, and it would continuously move backwards. I decided to go in that approach because if there ever was a case where the last object needed to push back and nothing existed behind it, it would just be something pushing information to a null pointer, and that does absolutely nothing. So it was kind of a way of fixing it. The next thing I should probably mention, well, there's singleton factories. There is a centipede explosion and a centipede head factory that I used. So much like the bullet factory, the centipede factory basically maintains the number of heads that are on the given field. So it basically at the very end increments its counter to say, hey, I have 1 head on the field, or I have 7 heads on the field. And when they are brought back into the factory, it decrements it. Currently, what the Wave Manager does with this system is it requests the knowledge of that system, and when there are no heads on the field, it asks for the centipede factory to just create a new centipede. So again, there's a lot of caller-callee communication between the centipede factory and the Wave Manager. I did end up having an infinite loop because a really funny thing happens when the game ends. It deletes all the heads on the field, and because it deletes all the heads, it also communicates to the Wave Manager saying, hey, there's no heads, and it tries to create a brand new centipede. So what I did to combat this this infinite loop is I just asked the game if its time has elapsed, and since the game has terminated, if the time has not elapsed, it basically just says, hey, I'm not going to make a new centipede because it's not going to go anywhere. Again, we ensure that at the very end of the day, all these centipede heads and body parts, which there are a lot, get completely deleted to save memory. The thing about the centipede explosion is that I use it across multiple game objects, because all game objects use necessarily the same explosion. So I use it for when the blaster gets destroyed, for when centipedes and when centipede head and body parts get destroyed. And this section of code is very malleable to fit. It's called within any class, because every single object has a position. It just feeds it its position, and it creates an explosion at that given spot. And since the explosion looks the same regardless of what creature it is, it was just a quick and cheap way of reusing the exact same code without much refactoring. Next thing, the flea. The flea, it has its own individual factory, and apart from the factory, it has its own spawner, which again, it everything is always kept track on the number of fleas that can be on the screen and the number of the max number of fleas that are wanted at any given point in time. But this counter will always ensure that there's only one flea on the screen at any given point. And if there isn't, it will just ask the flea factory, hey, flea factory, create me a new one, and I'll set an alarm so that I create a new one at a later point in time. But going back to the flea, flea is generated somewhere randomly within the top row, but it's never going to be at one of the extreme edges, just because I didn't really like that feature, but it can be changed if the designer, for some reason, God forbid, wants that. Apart from that, its update, the only thing that it updates is its Y position. There's no reason to update an X position. It's going up and down the screen. And the other thing is it will randomly spawn a mushroom given a 1 in 3 chance after it crosses any one of the center points of the square grid. And then, again, it's marked for destruction once it leaves the screen. So what the flea, in essence, what all the game enemies do upon collision with a bullet is they basically they all use the strategy pattern of calling the game controller to update the score, update the condition if the player gets hit by the flea, by changing either the score or the life. And the score manager, the game controller, does a few other things other than just maintaining score. It also writes to a file over here that I call the high score text, where it saves the highest value, or the highest score upon a game over. It doesn't maintain names or anything else. I didn't have time to implement those features, but I at least have the top score saved on file. Once again, it has its factories. The thing about the HUD uses the flyweight pattern as provided in class with the awesome font example. Again, it was the one that you showed us how to do. One thing that I wish I did do in turn with this is implement this as a factory. I didn't have time to go through it, but I should implement it as a factory. The HUD again basically calls, when the HUD gets created, it creates a new game controller instance. I did ruin the game controller because it was the first singleton I created, and I accidentally called the instance. None of my factories actually do that, thank God, but the HUD calls the instance to create the game controller. It's something that should be changed because you should never call the instance, but we're going to leave it be for the time being. So continuing on, the game takes the score, takes the lives and the high score, and puts them all, draws them all the way at the top of the screen. This HUD system also is not the most efficient. What it should do is only update the screen when it receives a ping from the game controller that the score or the lives have changed. Again, it's a little something that should have been fixed. The one thing that I was proud of that a few people actually asked me for was the thing I did with the the font map. So here's the font map. As I mentioned before in a previous sprint, I just added the centipede head to the very end of this row and column. So when I use the ampersand symbol, so to speak, I actually just print out the heads. So that kind of saves the creation of another flyweight pattern that, again, wasn't needed. Much of my code is trying to refactor as much of it as possible so that it can be basically elastic and work with less classes and less writing of code. Here's the game controller. Like I said, it's a singleton, but it's a messed up singleton where the instance is public. Again, that was a complete mistake on my part, and it's something I should have fixed. But in general, the game controller basically sets everything. It reads the highest score, takes it, saves it, puts it on screen. The game controller can reset scores when there's a full game over. The add score system adds to it, gets score. When the player dies, we change the scene and go all the way. When there's no more lives, when there's no more lives, the game just completely starts over. If there is a live, the game completely starts on a brand new level. And if there are no more lives, then it saves the current highest score, and it just takes you back to the attractor mode. What this should have been was the moment where the mushrooms regenerate back to their full health from being destroyed. But again, timing kind of levied my hand. Splash controller, that's already basically talked about. So moving on to the game field, we see an example of another example of a factory where we have the game grid fully on a 30 by 30 array. One thing that I did want to mention is there were some weird occurrences where sometimes if I did not initialize the game grid to a null pointer for each individual thing, there would be a bit of a few issues. But at the end of the day, I changed this system so that I changed the system so that the null pointers were always guaranteed at the start. This does take up a little bit of time at the very beginning of the game, but it's at the very beginning, so it's a price that is best paid for at that instance. The game field currently is only responsible for adding mushrooms onto the field itself and keeping track of where those mushrooms are. When the game field needs to know if a mushroom is poisonous, or when a player needs to know, they will contact the game field, give it a position, and the game field will ping back to the mushroom field and ask if it is poisoned. If a critter crosses a mushroom, the game field will say, hey, is a mushroom there? Oh, yes, a mushroom is there. And these things occur. I'll skip on a little bit because I think I'm rambling or going a little past time. So this inspection is what is mainly used for the finite state machine, just ensuring if an obstacle is blocked, if an obstacle is clear or poisoned. Again, poisoned is done by asking a mushroom itself if it is poisoned. The game grid as mentioned before, only knows the position of the mushrooms and their pointers, and it is the job of the individual mushroom to hold its state, its health, etc. There are all the other critters. Each critter does mainly the same as previously mentioned with the flea. There aren't that many differences except for the directional things. The centipede and the spider all use the finite state machines. Further talking about other design patterns, we can bring up. We've mentioned the finite state machine, factories, singletons, the flyweight patterns, the observer patterns, to where the way in which the game field communicates to the mushroom, and when the mushroom dies, it calls back to the game field saying, "I'm gone." The strategy pattern is one of the very first things I believe I showed with how the blaster's update occurs. But there are a lot of examples of files, not of files, but of classes contacting other classes only when things need to, when information needs to be updated. There's a lot of instances where this happens, but the main things that I can just point out are the factories, the singletons, and those. I think I have covered almost everything in terms of these examples. The explosions, the bullets, all the critters are all the critters are active. I know there is a couple bugs in the process, and there are a few features missing, but a lot of what I tried to do was get the game in a state that was fully playable, and a state where, at least for a single player, not the competitive, I want to win a high score type player, gets the ability to play the game to as close to the original as possible. A lot of the choices I made at the end were basically trying to manage time and make changes that still kept the essence of the game, but didn't necessarily have the features for. One thing that was not implemented was the sound manager, but I believe I have almost every other type of manager, but a few features missing. I think I've covered almost everything, and I think that will have to do. I'll sign off. Thank you, Andre, for your time, and we'll see what happens.